Welcome back to some more geometry. Today we are talking about angles. Last time we talked about segment relationship. We're talking about angle relationships. Let's see what's so special about these angles right here. All right. So just like a segment addition, where you can add two smaller parts to make a bigger part, there is an angle addition postulated in the same manner here. So they're saying, all right, so D right here, this D is a point in between angle A, B, C. So the whole angle is angle ABC. That's the whole thing. Well, we could say, hey, angle ABC is angle ABC because we're able to take angle ABD. Sorry, I had to take a breath. So that angle right there, plus the measurement of angle DBC. So understand B is the middle point because that is our vertex. So ABD plus BDC equals the whole thing ABC. You can also split it up. You can say, hey, the measurement of angle BC, the measurement of an angle ABC is equal to the measurement of ABD plus BDC. That's a symmetric property right there. So, excuse me. Whew, I had a sneeze. All right, so find one. So find the measurement of angle 1 if the measurement angle 2 is 56. Let's put that in. So this is 56. And then the measurement of JKL, so that's the whole thing. The measurement of the whole thing is 145. Right there. So we can pretty much say, hey, the measurement of angle 1 plus the measurement of angle 2 equals the measurement of the whole thing JKL. That's the general idea right there. So let's go ahead and then substitute information we do know. We don't know angle 1, so we'll leave that as the measurement of angle 1. We do know that the measurement of angle 2 is 56, and that equals the whole thing 145, the measurement of the whole thing 145. So using good old algebra, what are we going to do, class? What do we do? Yep, we're subtracting 56 minus 56 both sides, leaving us the measurement of angle 1 to equal, what would that be? I don't know, actually. 145 minus 56. Yes, good job, y'all. 89. So the measurement of angle 1. So this is how you use it geometrically, and that's how we kind of used algebraically. We already kind of done some version of that. Now we're looking at a bigger picture idea. All right, so let's kind of go over some more definition things. So some couple more theorems to talk about is the supplement theorem says that if two angles are linear pairs, so this is the difference between this and other things we'll see. The supplement theorem says that we know these two angles are linear pairs. So we have a linear pair, then that means those two individual angles added together equal 180 because linear pair, as we said before, linear pair equal 180 because a line, well, I spelled that wrong, there you go, linear pair. Because a line is a 180 degree measurement, so a linear pair means two angles that equal 180 together. Now the complement theorem says that two angles in a right angle are complementary because together they form that right angle together. So same idea as supplement. There we know that they exist in a certain boundary. Now, just like segments, just like numbers, just like anything, there is the concept of congruency. So congruency means, and there's different properties. So reflective property, as before, says, hey, the same angle is equal to itself. It's kind of looking in the mirror. What you see in the mirror is who you are. It's a reflection of yourself. So the same thing equals the same thing. Symmetric property is just certain ways you say it. 1 equals 2, 2 equals 1. In this case, angle 1 equals angle 2 equals angle 1. But then the transitive property, as we said before, hey, angle 1 equals angle 2 equals angle 3. So by transitive property, angle 1 equals angle 3 because we slowly said that this is equal to that, which is equal to that. So first thing equal to the last thing. Other things to consider right here, congruent supplement theorems. Very similar to transitive property, in the sense that it's saying that, hey, just look at this if right here. If angle 1 plus angle 2 equal 180, here's the thing, we don't know that these two are equal. We just know that these two equal 180. If angle 1 plus angle 2 equals 180, and angle 1 plus angle 3 equals 180, that means, by the congruence limit theorem, these two have to be equal. Let's use numbers. So let's pick the number 89 right here. So 89 plus 91 equal 180. Okay? So we know that this angle 1 is the same value the whole time, 89. That means these two have to be the same value for both of these equations equal 180. 1 plus 2 equal 180 and 1 plus 3 equal 180. It means these two have to be equal to each other. That's what the congruent supplement theorem. We're looking at supplement angles that eventually you see the congruence between different angles. And the same thing is true for complementary angles. If 1 plus 2 equal 90 and 2 plus 3 equal 90, then these two have to be equal to each other. Because for them two together, this to make 90 with 2 and 1 to make 90 with 2, these two have to have the same value because 2 is the common thing in between them, has the same value. So that being said, let's kind of make a proof off that right here. So let's take right here. So we're saying angle 1, this is the given, so this is information. Angle 1 and angle 3, I'm going to write down, are complementary. I'm going to shorthand it. And angle 2 and angle 3 are complementary. Okay, so that's given. So let's take the general idea here. So we know that angle 1 and angle 3, so I mark out these different because these are two different angles. We don't know what their exact values are, but we do know that they are complementary, but they're not necessarily the same. So 1 and 3 are complementary, so they equal 90, and then 2 and 3 are complementary. We want to prove that these two are congruent. Okay, so kind of go semi the long way right here. So we know 1 plus 3 are complementary, so that means angle, the measurement of angle 1 plus the measurement of angle 3 equal 90 because they're complementary. And we can say the same thing about the next line. The measurement of angle 2 plus the measurement of angle 3 are complementary. That is just definition of complementary angles. Complementary angles. We know that because by definition, anything that's complementary, two things equal 90, as we said earlier. Where did we say? We said it right here. And then it's necessarily not the congruent, it's just complement angles. We know that they equal 90, and we talked about that last section, or not last section, but the last chapter. So if these two are complement, they equal 90. That's by definition of what they are. So if both these things equal 90, 1 plus 3 equals 90, and 2 plus 3 equals 90, so this is 1, this is 2. So by substitution, because again, ultimately we want to get 1 on one side of the equal sign and 2 the other side. So we'll start with this. We can then say the measurement of angle 1 plus the measurement of angle 3 equals this right here. The measurement of angle 2 plus the measurement of angle 3. We just substituted this in for the 90. That's just substitution. Substitution property. All right. Now, the goal ultimately is to get 1 and 3, 1 and 2 by themselves. So we got to get rid of these 3. So before we do that, we state this. We call, hey, FYI, the measurement of angle 3 is equal to the measurement of angle 3. When the same thing equals the same thing, and we're just stating that, that's reflective property. Reflexive, not reflexive property, because that's reflexive property. Now that we know the same, we could just get rid of it. We could subtract it. We're not getting rid of it, but we're subtracting. We're saying minus measurement of angle 3 minus measurement of angle 3 to just say this. The measurement of angle 1 is equal to the measurement of angle 2. We subtracted the same amount, so that is just that, the subtraction property. We subtracted that, but we had to state that those two angles were congruent before we can do that. And now we want to say that they're congruent, so we just drop the measurement and say congruent. Angle 1 is congruent to angle 2. That's a horrible congruent sign. My bad, y'all, my bad. Let me fix that. not one to be really OCD, but that just looks awful. All right, here we go. Not the measurement. Angle 1 is congruent to angle 2. And by that definition, that makes it, what did we say it was? It was definition of congruency. Congruency, or just C-O-N-G. That's what it did right there. Okay? Take time to kind of go back over these and listen to those steps again if you're confused at how we got to the point that we're at. But that being said, I'm going to move on. So the vertical angle theorem is something we already kind of talked about before, but we got to state it. Angles that are vertical to each other are always congruent. And that means when two lines are intersect each other without any like weird change, like sometimes you get a line that goes like this, but then it goes like that, that's not a line. That's not a line. So two lines intersect, forming angles that are across from each other. Those angles are congruent to each other. So 1 and 3 are congruent, and then 2 and 4. That is something that will say is 100% true from here on out. That is 100% true. Okay, we're going to skip that proof. Let's look at other things real quick. The right angle theorem says that perpendicular, and that perpendicular is saying that, hey, they put a little right angle here, like perpendicular, and sometimes the symbol for perpendicular is the upside down T. They'll say angle, they'll say line, something like CE. Let's say this is CE and AB. AB. You'll see this like this. You'll sometimes see it as CE. Segment CE is perpendicular to AB. So that upside down triangle right there means perpendicular. Means it forms a right angle. So perpendicular lines intersect to form 4 right angles. So all 1, 2, 3, and 4 here, they're all perpendicular. And of course, all right angles are congruent, because to be a right angle is to equal 90 degrees. And to equal 90 degrees means to other things means all 90 degrees equal each other. So all right angles equal each other. Ooh, the hiccups. Now, perpendicular lines form congruent adjacent angles. And what it's saying that is, this is 90 and this is 90, and these two angles are adjacent because, one, by angles, just by definition, they're adjacent because they're right next to each other. They don't have to be equal. But perpendicular lines means that they are not only adjacent to each other, but they're also congruent. Also congruent. Very important to remember there. They're congruent. And the last couple of things to talk about here is, if two angles are congruent, if we know they're congruent and supplementary, the only way two angles, so say angle 1 equals angle 2, and then angle 1 plus angle 2 equal 180. For the only way they can both equal each other and both together equal 180 is if they're right angles. They're 90-degree angles here. So that's the important part right there. And if two congruent angles are a linear pair, so they're a linear pair, and we know for sure that angle 3, so they're a linear pair, then we know for sure that equal 180 because they make a line. But then they're also congruent. Angle 3 is congruent to angle 4. The only way that can happen is if they're both 90-degree angles. So hopefully all those little theorems right there will help you. And again, you'll use these theorems as a reason why you're allowed to say certain things. Okay, so y'all have a great day. Actually, we're not going to do this only because I don't think we're deleting one of these problems. So we're going to skip that. Anyways, if you have any problem, which I'm going to tell you right now, this section right here is not the most difficult, but sometimes it's a big brain. It's really hard to kind of really grasp it. So kind of rewatch this. But if you have any questions, please feel free to email me, message me, let me know, y'all. All right? Have a great day.